Hello everyone, I'm Dr. Vidit Kumar Das, and today we are going to discuss about a practical to determine the internal resistance of a cell by using potentiometer. Now the apparatus required for these experiments are potentiometer, a rheostat, a battery eliminator, a resistance box, emitter and voltmeter, a galvanometer, two one-way keys, a Lagrange cell, and connecting wires. Now before starting the experiment, let's understand what is a potentiometer. The potentiometer is an instrument which can measure accurately the electromotive force of source without drawing any current from the source or the potential difference across a circuit element. An unknown potential difference is balanced against an adjustable measurable potential difference. So this is the circuit diagram of a potentiometer. A uniform wire AB of length 100 cm, which in more accurate instrument is 10 meter, is connected to the terminals of a source E1 having EMF E1. The current through the wire can be varied by means of an adjustable resistance R1 connected in series with the wire. Now if the terminal A is connected with the positive terminal of the battery, there will be a continuous fall in potential from A to B along the wire. Now consider a source E2 in such a way that its positive terminal or positive pole is connected to A and its negative pole through a galvanometer G to a contact sliding on the wire. Now if the EMF or electromotive force of this source is less than the potential drop along the wire AB, it is always possible to find X on the wire at which galvanometer shows no deflection. At this position, the potential drop along AX is equal to the EMF of E2, and we call the potentiometer as balanced and the point X as the balanced position. Now if the wire is uniform and its properties are not affected by alternating its electrical potential, the potential difference between any 2 points in the potentiometer wire is directly proportional to the length of the wire between them. Now let's discuss about the theory of the experiment. The circuit diagram of the potentiometer is almost same with the previous one. What you have to do here, only you have to insert a resistance parallel to the cell which you are going to find out the internal resistance. So this is called the shunt resistance, and the internal resistance of this cell which we are going to use Lagrange cell. The internal resistance of this cell is given by L1 minus L2 divided by L2 into R, where the L1 and L2 are the balancing length without shunt resistor and with shunt resistors respectively, and R is the resistance which is in parallel with the cell E. Now to find out the internal resistance of this cell, let's go to the laboratory. Now the procedure of this experiment is very simple. So what you have to do, first you have to connect the connections of this potentiometer like this. So there are basically two sections of this circuit. So this part of the circuit is called the primary circuit and this one is called the secondary circuit. So first you have to find out the balancing length of this potentiometer without connecting this resistance. So this way you have to find out L1. And simultaneously you have to note down the current value showing on the ammeter. So in the second step you have to connect this resistance by closing these keys, and you have to find again the balancing length L2, and simultaneously you have to note down the current value. So in this way you have to collect 5 to 10 numbers of data by varying this resistance. So this is the experimental setup. So we have connected already for demonstration purpose. This is the battery eliminator, and the positive terminal of the battery eliminator is connected to the potentiometer at this point, and from that point the two-way key is connected, and from two-way key we have connected to a rheostat, and from rheostat it is connected to the potentiometer at that point again. So this is the primary circuit of the potentiometer. So this is the Lagrange cell, and this is the positive terminal, this is the negative terminal, and the positive terminal of the Lagrange cell is connected to this potentiometer at the same point where the battery eliminator, positive terminal of the battery eliminator is connected. The negative pole of the Lagrange cell is connected to a one-way keys, and then from one-way keys it is connected to a galvanometer, and from galvanometer it's basically connected to a jockey. So this is the jockey which is connected to the galvanometer. So from this jockey we can find out L1 and L2 as we have discussed in our theory section. So let's first switch on the battery eliminator. So in order to find whether our connection is correct or not, so we just put this jockey at one end of this potentiometer, and we'll check the deflections of the galvanometer. So in this case it is showing in the left hand side deflection, and again we put the jockey in the other side of the other end of the potentiometer, and it will showing the it is showing that it is deflected in the right hand section of the galvanometer. So our connection is okay. So if it is if the galvanometer shows only in one side of deflections, then the connection is wrong. So in the first section we disconnect the resistance and we will find the L1. So that means without inserting or without connecting the resistance, and we need to find out the L1 like this way. So null point is somewhere here, and suppose so this is the null point which we are trying to find out. So see, there is no deflection on the galvanometer at these locations, so this is the null point, and we have to find out the position of this point by the scale inserted on this potentiometer. So this will give us the L1 value. So in the next step we connect the resistance by closing this one-way key. So now the resistance box is connected, which is parallelly connected to the Lagrange cell, and first we keep this resistance as 1 ohm, and we'll try to find out the value of L2, that is the balancing or the null point on the potentiometer. So you should always keep these keys tight. If there is a loose connection, so you will get a wrong positions of your null point. So again we'll repeat the same just before what we have done to get the L1 value. The null point is somewhere here, and again you have to note down this position by the scale which is inserted on the potentiometer. So you have to note down this reading, and this way you have to repeat by varying the resistance, and you have to take at least 5 to 10 data. So this is the experimental table to find out the internal resistance of an unknown cell, and as we have discussed earlier, so first you have to find out L1 without connecting this shunt resistance. Then in the second step you have to find out L2 by giving a definite value in the shunt resistance, and simultaneously you can find out the internal resistance. So in this way you have to collect 5 to 10 data, and at last you have to take the mean of this internal resistance, and that will give you the internal resistance of the cell. So during the experiment you should take some precautions. So first the EMF of the battery should be greater than that of the cell, and second precautions you have to take that for one set of observations the emitter reading should remain constant. Current should be passed for short time only while finding the null point. Rheostat should be adjusted so that initial null points lies on the last wear of the potentiometer. Cell should not be disturbed during experiment, and jockey should not be rubbed against the potentiometer wear. So these are few precautions you should always maintain during the experiment.